everyone. I was at KubeCon in London just this year, 2025, and I had the incredible conversation with Mason Johnson. Mason Johnson is an engineer at ngrok, and we dove deep into how they handle billions of requests daily across their global infrastructure. Mason shared fascinating insights about their edge network architecture, how they manage instant kernel provisioning, and the engineering challenges of running middleware at massive scale. I hope you enjoy this conversation. Let's dive right in.
All right, so I'm Mason Johnson. I've been at ngrok for about a little over 3 years. I'm a software engineer on our network edge team. So network edge, like our team handles kind of our core middleware type stuff, and it's mostly just concerned with getting bytes from point A to point B. We handle a little bit of security stuff, firewall things, and stuff like that. So.
All right. Now, without giving away any sort of internal numbers, stats, and secrets, right? Can you try and give people a broad indication of the scale of the network and what you're putting through in a points of presence and stuff?
Yeah, that's a good question. So, I definitely don't have numbers on the top of my head, other than I think we do close to like a billion requests on a couple day basis, and so it's
much bigger.
Yeah.
It doesn't expect the number to be so high. That's a lot of traffic. Right?
It is a lot of traffic. It is, yeah.
And this is a geo-distributed infrastructure, right? You've got
100%. So yeah, we have 8 or 9 distributed points of presence. We run in AWS, but we have data planes that run kind of all around the world. We have 2 in the US. We have Frankfurt in Frankfurt, Germany, AWS region, Singapore, Japan, Australia, India. Kind of distributed all around, and kind of cool. One of the cool things about that is you can, if you're familiar with ngrok, you can start tunnels, and traffic goes over those tunnels. Wherever the clients are that are trying to access your tunnel, they will ingress to the closest ngrok region, and then they'll find your tunnel eventually over like kind of our internal network. So we have that kind of global load balancing, which is a pretty cool feature for sure.
Yeah, I mean, when you're in a critical path for your customers, right?
Yep.
You can't be the cost of their latency is
exactly
that first byte.
100%. Yeah. So yeah, and ngrok is like you are going to incur a latency cost when you're using a middleware provider like we are, a hosted middleware provider. But yeah, like we try to be pretty careful about the things that we write. We're not making any network calls in the hot path, right? We're trying to do things pretty efficiently. Anything that we can compute ahead of time before your request comes in. When we're manipulating HTTP traffic, adding, removing headers, doing auth and that kind of stuff. Obviously, with some auth, there's some network calls that you have to make, right? But we minimize that as much as possible to kind of reduce that latency hit that you might take, which is.
All right, so let's try and get the people watching this an understanding of what the traffic patterns and shapes look like, right? So if I'm running ngrok as essentially my ingress to all my applications, so when someone comes to rockcode.academy, what happens from that point when the DNS is resolved, the ngrok ingress, and how does the traffic look?
Yeah, that's a good question. So ngrok is somewhat interesting in that we have 2 edges, right? There's the piece where when you install, so let's say you're using the Kubernetes operator and like our Kubernetes operator, and so you have an ngrok ingress or a gateway ingress class like ngrok. So or you're just using it from the CLI tool, right? Either way, you're establishing a connection back to the ngrok SaaS, and then we hold open that connection, right? And so there's that leg of it where wherever you're ingressing in, we're creating a tunnel back to the ngrok hosted platform, right? So that's one leg, and that's kind of one side of our ingress. And then on the other side, it's like, okay, now I have this tunnel established in ngrok SaaS, right? But like my customers or your customers, right, want to access the tunnel right through that URL. So that's kind of the other side of ngrok, and so that's kind of our other edge where we're ingesting like the client traffic. So generally speaking, like if you're gonna, if Raw Code Academy was .com, right, was like hosted on ngrok, you'd have a custom domain, and basically you'd be CNaming, your whatever domains you want us to host to an ngrok servers, and we'd handle that kind of global load balancing for you, the certificate. We can do automated like certificate provisioning and things like that. So that kind of first byte. So if I'm going to, rawcodeacademy.com, it's going, I'm going to get the CName typically, and that's going to hit, I'm going to get like a globally, or like a geo load balanced DNS record for whatever my closest like ngrok region is, right? And so I'm going to hit ngrok like on our edge, on that kind of customer edge. And then we got to figure out like where does this traffic go, right? So when traffic hits our edge, for like a website like Raw Code Academy, we're going to typically look at the SNI, like SNI in the TLS like client hello, and like that's how we're going to figure out like, okay, we know what tunnel this matches to, right? And that whole process is actually probably one of the more difficult problems that we have at ngrok, right? Is like we have this tunnel somewhere, right? This tunnel could be in a totally different region somewhere else, right? And we have this like packet that just came in that said, hey, I'm looking for rawcodeacademy.com, right? Like how do we match those two things together? Yeah, so, and this is going back to kind of like us trying to pre-compute everything that we can, right? And so every, like the ingress point, right? When you come into our servers, you're looking for Raw Code Academy, we're looking up that SNI, right? And we're saying, okay, this is Raw Code Academy, and we have like this, you know, generally an in-memory map of like, okay, Raw Code
service registry. This is
yeah, it's a very similar, yeah, exactly like a service registry, right? When you say like, okay, like this URL maps to this tunnel, and so when you created that ingress to begin with, and you created that tunnel back into like our service, back on kind of the other side of ngrok, right? So we look up that configuration, right, and then we kind of build like that runtime chain of like, okay, so we're going to come through, we're going to add or remove, you know, if it's an HTTP request, then we're going to add or remove this header, we're going to like go off and do an OAuth handshake. And so we look that up, we run it through that, and then the end piece is like kind of the more difficult one where it's like, okay, now we have to figure out where is that agent actually connected, right? And so part of that mapping when you created the tunnel, that part of the stuff we're pushing out is you're just like, I'm on this specific tunnel server, right, at this specific port, and we push that as part of the configuration. And so after we've run all of our kind of middleware stuff, we just like look up that port and we send a little preamble. We wrap that in TLS and we send that to like wherever your agent is connected, right? And so that's going to go over like generally the internal AWS network, but that might be in a different VPC than like where, you know, the customer's coming from, depending on where you're starting your ingress and where the customer's like bringing traffic in. So,
yeah. I just want to make sure I understood this right.
Yeah.
So let's make up some fake numbers so that we can make this approachable. Let's assume ngrok has 10 customers.
Yep.
And 10 domains.
Okay.
You store all of those in memory at the edge locations in that, including the traffic policy rules for each of those.
Yeah, precisely. Yeah. So, yeah.
So do you have like I mean, I don't know how much that's going to be, but I mean, if you've got 1,000 customers, 10,000 customers, 100,000 customers, this is an exponential, well, not exponential, it's a linear scale problem. Is how much RAM can I put on that machine? Is that exactly going to bite you in the ass?
Yeah, it's a problem that we're gonna have to tackle at a certain scale, right? So we try to do tricky things like we have the configuration. So basically, like you know, when you create your tunnel, the actual configuration we store that in protobuf, pretty small, right? And that's the thing that actually gets synced. And then we try to be a little bit tricky about like let's lazy load the actual business logic, right? Like eventually, I'm gonna have to like let's say we're doing compression, right? I'm gonna have to load up like in Go a compress writer or a compress reader or whatever, right? And I have to run the traffic through that to compress it. Like that piece takes a lot more memory than like the protobuf definition, right? And so we do like try to like, we don't load that business logic stuff. We don't build like kind of the handler chain until like a request actually comes through. So yeah, we have to get a little tricky about that. That's something that we're, you know, gonna have to figure out at some point, right? At a certain amount of scale of like, how do we, you know, take that to the next level? Like, is it enough to be able to store that outside of like in memory, right? And look it up like at request time, right? But now we're talking about like, oh, like now it's the hot path, you know, we're adding latency.
Yeah, I think you know that's your challenge, right? You've done it this way because the hot path is you can't go adding 10 or 50 milliseconds to someone's request because
if it's a database lookup, that is literally you know, however long the database lookup takes is exactly, you know, adding that onto the request time.
Yeah. I mean, I guess with modern Linux kernel advancements and IOU ring and NVMe disks, right? You could probably get pretty fast to keep that long back. But you know, if you don't need to have that yet and you can let it run, that's a pretty nice situation to be in.
100%.
And the fatty areas and protobus and stuff there are really cool too. Yeah. So we got the SNI request, we've got some sort of in-memory lookup that says, okay, we need to get this traffic with these policies over to this tunnel or somewhere else in the infrastructure. All right. What other technologies are you using then to make all of this work? Because there's a lot of complex problems here. Right? I'm assuming you're not just writing it. Well, maybe you are writing a ton of Go code and doing it all yourself, but do you lean on open source project?
So it's a good question. We have a pretty good mix. So we make very, very heavy use of gRPC. So a lot of this, like the in-memory maps, right, that we're keeping track of, like, you know, the mapping of like this SNI maps to this configuration, like a lot of that is going to be just stored in protobuf, but the kind of mechanism to sync that, make sure that's always up to date, is a lot of times just gRPC streaming and kind of our own way of handling basically like adds and deletes, like those kind of things, and making sure that the store is always up to date with the source of truth, right? Yeah, that's a fairly difficult problem. A lot of that is stuff that we built ourselves. We are like starting to use like SQLite as a way to just like we're basically doing create selects and those kind of things, like using SQLite but still in memory. which is pretty interesting, I think.
I think it's SQLite, SQLite. I'm not sure what the current
Yeah, SQLite, sorry. Yeah.
But it's such a cool project. I don't think people always consider it a toy database, and I'm like, you can put some shit through that. Like,
100%.
which is terrible. You can do a lot with SQLite,
Yeah.
I think. And if you look at Android applications and iOS,
Yeah, they're all like, right, that's all SQLite, 100%.
I'm not sure if you're familiar. There's a really cool project where they rewrote SQLite in Rust. And it does replication, and it's called Turzo, and the open source component of it is called SQLD libSQL. Really, really cool project, but that's the segue that we don't need to do. All right, I'm curious then, right? Now, you've got this hot path, you've got the in-memory lookups, but I'm now curious about the aspect of, I decide I've got a new domain, say rockcode.vip. I need to get this on the ngrok network. And I go to maybe I start a tunnel, maybe I do it to the UI, doesn't really matter. But there's a write request that goes somewhere that's got to get into that memory map. Like I'm assuming with live reloading, how are you orchestrating that to make sure? I'm assuming the latency there is important too. Once I create that mapping,
it's kind of time
I don't
to
want to
push
measure
request,
consistency
right?
of 40 seconds, right? I probably want that to be pretty fast.
Yeah. So that's a good question. That's another thing that's, I'd say, like talk about some hard problems. That's probably like our next hardest problem, right? Is like making sure that like when you start a tunnel, like let's say I'm in the US and I start a tunnel, I want to be able to access that from Australia, like in a very short amount of time, right?
Exactly.
And so, we have basically an internal service that goes through and it's getting those kind of real-time updates. Like, so any change to like an account that you make at ngrok, right? If you're changing like your auth tokens or what domains you've registered, right? Any of like all of those kind of changes, they trigger like an asynchronous basically path that's going to go through and say, hey, this change just happened. And then we have a service that really the only thing that it does is like listens to all those changes, right? And then it says, okay, like that's how this changed your endpoint. And then it immediately pushes that back out to like our edge servers, right? Which are like the kind of business logic, the configuration for your endpoint. And yeah, so it's continually basically like listening to like account changes, tunnel changes, all of those things are going to basically emit events more or less that get picked up by this service. And it's just chugging through basically as fast as it can, like all those changes. And so the interesting thing there too, though, is that let's say, I make a change in the control plane. That's kind of easy. There's only one source of truth, right? But if I change a tunnel that's running like in the US, like that change has to make it back to all of the other regions that we have, right? That tunnel is updated, like those tunnel updates have to make it everywhere. And so we have a syncing mechanism. So we have this service that runs in the data plane that's continually chugging through and reading those changes and updating things and pushing them to the edge. But a change, that happened in the US, like that change has to be reflected in all the other regions. And so this service, that internal service that's chugging through changes, it's continually also syncing those changes to all the other regions. And again, I use like pretty heavy gRPC streaming is kind of our main mechanism there. Yeah. And a little bit of SQLite and stuff as well. So we're kind of moving that direction.
All right, I'm going to get. I don't know if I'll keep this question in, but I'm going to ask it. Because it's more of a Go question. For anyone listening to this who's not familiar. To the best of my knowledge, this has never changed, but a Go map, the iterate over that is random, right? It
is, yeah.
So I'm assuming you're using a slightly different data structure in memory to kind of avoid that and get some sort of constant time lookup, or are you just going straight over that map and trying to find that SNI record? That's a completely random question, but I'm curious.
No, yeah, it is a good question. Let me think about the actual mechanism here. So we have, for SNI, so the lookup mechanism, that's a really good question. Whether that's a Go map. We do typically use just like standard lib maps, like in the vast majority of places, I would say. I'd have to look at our code to think about like where
this question. Yeah, I think I'm really curious about that.
Yeah, that's a good question.
All right, I think I've got one more question. I don't know if there's anything else you want to touch on, we'll go through it, right? But I'm now worried. I'm now curious about the fact that done the SNI negotiation, we've found the map, you've pointed me to a tunnel. Are you doing anything with HTTP2 there that my next request or any subsequent requests are going on a slightly different path, or does everything come in as fresh as the same way? Like, is there connection pooling? Is there long-lived connections, WebSockets? Like, how does all that work?
Yeah, we're mostly just using kind of the underlying protocol with the built-in kind of stuff there. I don't think we're doing too much. I have to think about that a little bit. I don't think we're doing too much in the like optimization of that, where like sticky sessions are always going to like hit the same endpoint. Generally TCP connections are going to stay open for a little while. Normal HTTP 1.1 like keep alive stuff and things like that. We do run into some interesting issues with like using gRPC and like making sure that like gRPC connections are load balanced and like those are like an H2, the underlying protocol there is H2. But I don't think we we don't run into too many issues where that goes, like where we have to optimize that kind of stuff. We do deal with like a lot of long-lived connections, like TCP connections, right? Like you can you can open up a tunnel to your local host, like for SSH, right, in 422. And like that connection is always going to be from the same edge server, wherever you're in, to the same tunnel server that the other end is connected to. But for HTTP, I think we're mostly relying on just kind of the underlying protocol there to make sure that things like whether they're going to flow through the same path or create a new TCP connection on request and things like that. So
awesome, thank you. Is there anything else that you think is interesting from the way that ngrok are handling stuff that you would like to talk about before we wrap this up?
Sure. Yeah. Let me think. I do think that like one of the things for me that's really interesting about ngrok is like the automated cert provisioning. Like the fact that you can offload that to us completely is like pretty huge. And it turns out it's actually pretty complicated to manage thousands of certificates, right? And they're all like, you have, Let's Encrypt. So we typically use Let's Encrypt to get certificates. You can upload your own if you want, but you can just say, hey, I want to serve this this tunnel at this domain, and like we'll figure out the certificate for you, right? And so we're using Let's Encrypt, but there is a lot that goes into that where, we have thousands and thousands of certificates that we're making sure that they have to stay renewed, right? And like, there's that, we talked about like when tunnels change, like how does that get updated? Like that is certainly another thing where like, hey, the certificate's about to expire, we've got to update your tunnel, right? And so, there's a pretty big source of events that that come from, certificates being updated and renewed and things like that. So I just think being able to, it wasn't that long ago that setting up like TLS was like a huge pain. Right? And expensive, right? Yeah, exactly. $200 for a certificate or whatever. Right. And so,
well, it depended if you went for domain verification or extended verification.
Yeah, 100. Yep, exactly.
People made money off this as well. So.
100%. And so now, like ngrok, like I can bring my own domain, set up one DNS record, and then I don't have to worry about certificates. And like to me, that is like a huge like value add, right? Like it's all TLS, like, and we can enforce mutual TLS, like all those kind of things. I do think the certificate management aspect, like we do spend, there's a lot of kind of business logic that we have to keep track of to make that system work. But I think that's a huge value add that you're not having to deal with that, right? Your certificate's never going to expire. We're going to make sure that it's renewed, like when it's time to do that. And so, to me, like that is a pretty big piece of like why ngrok is pretty cool. Is like being able to offload all of your certificate stuff to us for sure.
Yeah, I love that. I mean, I've had conversations with a few members of the ngrok team now, and I think the thing that always makes me smile when I do use ngrok. Like, ngrok isn't my production infrastructure. After you power the entire ngrok, is that attention to detail and providing simple API on a complex topic. And I love that, right? You're just making it a single flag, a single checkbox, a single layer, and like to enable so many very cool features.
That's awesome. And I think we do try to like really keep that in mind, right? Like for a long time, we've always said like online and one line, right? And then you get to like Kubernetes ingress, it's like, okay, like we're, like I've got to write a YAML, ingress kind or whatever kind of ingress. But we do try to like keep that, as simple as possible. And I think we're doing a pretty okay job at that, right? Like we're doing pretty well, like making sure that like you can be an application developer, you don't have to have experience like running, network infrastructure at scale or anything like that. And you can, write your business logic and let it do your stuff. So,
Awesome.
So,
all right. Well, thank you so much for your time.
Yeah, appreciate it. Thanks for coming.